Welcome to lecture series EPG Padasala for Computer Science. In this lecture, we will be discussing function point analysis. Learning objectives: discuss the limitations in using lines of code as a standard metric, describe how a project can be decomposed according to its functionality, outline the different steps in function point analysis. Introduction: the ability to estimate the associated cost of development early in the development process is vital in the software development process and has an impact on the quality of the software product delivered. Estimating software size is a difficult problem that requires specific knowledge of the system functions in terms of scope, complexity and interactions. Most frequently cited sources of software size metrics are lines of code and function point. Lines of code: first measurement attempted, simplest and most widely used metric, easily recognizable, but uses different approaches. One approach do not include data declarations, comments or any other lines that did not result in object code. Another approach include declaration and any other unexecutable statements, but exclude blank lines and comments. Problems with lines of code: lack of an universally accepted definition, language dependence, high level versus low level programming languages. It is difficult to estimate the number of lines of code needed to develop a system from the information that is available from design phase. To be more clear, with the information available in the analysis phase and design phase, it is difficult to estimate the number of lines of code. Lines of code places all emphasis on coding, which is only part of the coding phase of a software development project. Function point. Function point is designed to estimate and measure the time and thereby the cost of developing new software applications and maintaining existing software applications. Measures software size by quantifying the functionality provided to the user based on logical design and functional specifications. Uses of function points: measure productivity. Example: number of function points achieved per work expended. Estimate development and support. Perform cost benefit analysis and staffing estimation. Monitor outsourcing agreements, which ensures that the outsourcing entity delivers the level of support and productivity gains. Normalize other measures such as defects frequently require the size in function points. Function point analysis. Function point analysis is a method of quantifying the size and complexity of a software system in terms of the functions. It is independent of the language used, development methodology, technology or capability of the project team. Function point analysis principles. Project can be decomposed into functional units. Transactional functional type, which includes inputs, information entering the system, outputs, information leaving the system, inquiries, requests for instant access to information. Data function types: internal logic files, information held within the system; external interface files, information held by other systems that is used by the system being analyzed. In this slide, a diagrammatic illustration of functionality as viewed from the user's perspective is presented. We have the internal logic file to which an external input interacts. We have the external output, external inquiry, we have external interface file, external input, external output, and external inquiries. Approach to function points: a function point count is performed to produce a functional size measure. The size can be used to generate project estimates. Estimates should be based upon delivery rates. Analysis: plan versus actual comparisons. How good is the information received during requirements? How good or accurate is project estimating? Function point analysis. Step 1: determine the following components: external inputs denoted by EI, external outputs denoted by EO, external queries denoted by EQ, internal logic files denoted by ILF, external logic files denoted by ELF. External inputs: these are elementary processes in which derived data passes across the boundary from outside to inside. In an example library database system, entering an existing member's library card number. External output: these are elementary processes in which derived data passes across the boundary from inside to outside. In an example library database system, display a list of books checked out to a member. External queries: these are elementary processes with both input and output component and results in data retrieval from one or more internal logic files and external interface files. In an example library database system, determine what books are currently checked out to a member. Internal log files: these are user identifiable groups of logically related data that resides entirely within the application's boundary, maintained through external inputs. In an example library database system, the file of books in the library. External log files: these are user identifiable groups of logically related data that are used for reference purposes only and which reside entirely outside the system. In an example library database system, the file that contains transactions in the library's billing system. Function point analysis. Step 2: compute the unadjusted function point. Rate each component as low, average, or high. For transactions, external inputs, external outputs, and external queries, the rating is based on the number of files updated or referenced and the number of user recognizable fields. Based on the table below, an external input references 2 files and 10 data elements would be ranked as average. An external input that references 2 files and 10 data elements would be ranked as average. Now, to clarify the number of files updated or referenced and the number of user recognizable fields with respect to this table, if the number of files updated or referenced is 0 to 1 and if the number of user recognizable fields is from 1 to 5, then it is ranked as low. If the number of files updated or references is 0 to 1 and the number of user recognizable fields is 6 to 15, it is ranked low. If the number of files updated or references is 0 to 1 and the number of user recognizable fields is greater than 15, it is ranked average. Similarly, if the number of files updated or referenced is 2 to 3 and if the number of user recognizable fields is 1 to 5, it is ranked low. If the number of files updated or references is 2 to 3 and the number of user recognizable fields is 6 to 15, it is ranked average. If the number of files updated or references is 2 to 3 and if the number of user recognizable fields is greater than 15, it is ranked high. If the number of files updated or referenced is greater than 3 and the number of user recognizable fields is from 1 to 5, it is ranked average. If the number of files updated or referenced is greater than 3 and the number of user recognizable fields is from 6 to 15 or greater than 15, it is ranked high. For files, internal logic files and external logic file, the rating is based on the number of user recognizable data elements in an internal logic file or external logic file and the number of user recognizable fields. Based on the table below, an internal logic file contains 10 data elements and 5 fields would be ranked as average. If the number of user recognizable data elements in an internal logic file or external logic file is 0 or 1 and if the number of user recognizable fields is from 1 to 5, the rank is low. If the number of user recognizable data elements in an internal logic file or external logic file is 0 or 1 and if the number of user recognizable fields is from 6 to 15, the rank is low. If the number of user recognizable data elements in an internal logic file or external logic file is 0 or 1 and if the number of user recognizable fields are greater than 15, the rank is average. If the number of user recognizable data elements in an internal logic file or external logic file is from 2 to 5 and if the number of user recognizable fields is from 1 to 5, the rank is low. If the number of user recognizable data elements in an internal logic file or external logic file is from 2 to 5 and if the number of user recognizable fields is from 6 to 15, the rank is average. If the number of user recognizable data elements in an internal logic file or external logic file is from 2 to 5 and if the number of user recognizable fields is greater than 15, the rank is high. If the number of user recognizable data elements in an internal logic file or external logic file is greater than 5, and if the number of user recognizable fields is from 1 to 5, the rank is average. If the number of user recognizable data elements in an internal logic file or external logic file is greater than 5, and if the number of user recognizable fields is from 6 to 15, the rank is high. If the number of user recognizable data elements in an internal logic file or external logic file is greater than 5, and if the number of user recognizable fields is greater than 15, the rank is high. Converting ratings into unadjusted function points. External output, if the rating is low, the value is 4. If the rating is average, the value is 5, and the rating is high, the value is 6. Similarly, for external queries, if the rating is low, the value is 3. If the rating is average, the value is 4. If the rating is high, the value is 5. For external input, if the rating is low, the value is 3. If the rating is average, the value is 4. If the rating is high, the value is 6. For internal logic file, if the rating is low, the value is 7. If the rating is average, the value is 10. If the rating is high, the value is 15. For external logic files, if the rating is low, the value is 5. If the rating is average, the value is 7. Rating is high, the value is 10. Function point analysis step 3. Compute the final function point. Compute value adjustment factor based on 14 general system characteristics. Data communications, how many communication facilities are there to aid in transfer or exchange of information with the application or system. Distributed data processing, how are distributed data and processing functions handled. Performance, was response time or throughput required by the user. Heavily used configuration, how heavily used is the current hardware platform where the application will be executed. Transaction rate, how frequently are transactions executed daily, weekly, monthly, etc. Online data entry, what percentage of the information is entered online. End user efficiency, was the application designed for end user efficiency. Online update, how many internal logic files are updated by online transactions. Complex processing, does the application have extensive logical or mathematical processing. Reusability, was the application developed to meet one or many users' needs. Installation is, how difficult is conversion and installation. Operational is, how effective or automated or startup, backup and recovery procedures. Multiple sites, was the application specifically designed, developed and supported to be installed at multiple sites for multiple organizations. Facilitate change, was the application specifically designed, developed and supported to facilitate change. Now, computing the final function point, we have to compute value adjustment factor based on 14 general system characteristics. I will repeat the 14 general system characteristics: data communications, distributed data processing, performance, heavily used configuration, transaction rate, online data entry, end user efficiency, online update, complex processing, reusability, installation ease, operational ease, multiple sites and facilitate change. Function point analysis, weight each general system characteristics on a scale of 0 to 5 based on whether it has no influence to strong influence. Compute the function point as follows. Value adjustment factor is equal to sum of general system characteristics. Function point equal to unadjusted function point into 0.65 plus value adjustment factor into 0.01. Estimating lines of code based on function point. Convert function point to lines of source code. Language, lines of code per function point. First generation default language 320, second generation default language 107, third generation language default language 80, 4GL 20, assembler 320, C language 128, basic 107, COBOL 107, C++ 53, Java 2 46, Visual Basic 6 24, Delphi 18, HTML4 14, SQL 13. Consider an example of a stock control system. A company sells goods on the phone. If agents call the customers, customers call the agents and so on. Business operates successfully, but there comes a time for putting the whole in order. There occurs a need for developing a system able to control the whole stock from orders to payments. Our objective is to estimate how complex such system can be and predict how long it would take to develop it. Grouping functions into 5 categories: external inputs, customer, order, stock and payment details. External outputs, customer, order and stock details and credit rating. External inquiries, customer, order and stock details. External interface files, there is no external interface files to consider. Internal logic files, customer and goods file and customer and goods transaction files. Predicting every function's complexity is low, so the values can be presented in a table. External inputs, the multiplier is 4, the weight is 3. External output, the multiplier is 4, the weight is 4. External queries, the multiplier is 3, the weight is 3. Internal logic files, the multiplier is 4 and the weight is 7. So, we are computing the function point analysis 4 into 3 plus 4 into 4 plus 3 into 3 plus 4 into 7. So, the function points is 65. If we consider C++ as the programming language, effort equal to 65 into 53, 3445 hours. Now, we are arriving at the value 65 by referring to this, where for C++ you can see that the value corresponding to the function point is 53. 65 into 53, 3445 hours. Now, let us consider one more example, an attend master software system. Attend master is a basic employee attendance system planned to serve small to medium sized business employing 10 to 100 employees. The system is planned to have interfaces to the company's other software packages, human master which serves human resource units and wage master which serves the wage units. Attend master is planned to produce several reports and online queries. Data flow diagram, we have the external entities, process, data stores, employee attendance, human resources. We have the employee attendance file, we have other employee files, employee attendance inquiry, attendance warning letter, daily attendance query, daily attendance exceptions query, monthly attendance report, monthly attendance exception report. Now, here calculation of unadjusted function points. Analysis of the software system as presented in the DFD summarizes the number of the various components. Number of user inputs 2, number of user outputs 3, number of user online queries 3, number of logic fails 2, number of extended interfaces 2. You can see the different values, the count, weight factor, points. Now, if you look here, 1, the weight factor is 3, 1 into 3 for a simple case. For an average case and for a complex case. User outputs. Now, considering the case, you can infer that we have arrived at the value 81. To summarize, function points are easily understood by the non-technical user. This helps to communicate sizing information to a user or customer. Function points can be used to determine whether a tool, a language, an environment is more productive when compared with others. Function point analysis for a case study stock control system has been illustrated in this lecture. It is assumed that general system characteristics have no influence on the function point. A case study illustrating the influence of general system characteristics will be discussed in the next lecture. I acknowledge the authors of the books which I have referred and the web resources I have used for this presentation. Thank you.